Resultant force is that single force which produces the same effect on the body as the net effect of all the forces. What is equilibrium? The particle is said to be in equilibrium if the net external forces acting on the particle is zero. Rolling friction has a complex origin. It is slightly complex, okay, and somewhat different from that of static and kinetic friction. Hello students, welcome to this second session on chapter 4, which is on laws of motion. I am Madhu R from the Department of Physics at Vidhyaashram PU College, Mysuru, your temple of excellence. In the previous session, we had studied about the first, second and third laws of motion. Let us continue from the third law of motion, where we were discussing about momentum and third law of motion. We are continuing our study on linear momentum, where we are talking about conservation of linear momentum. What is conservation? Okay, the statement says the total linear momentum of an isolated system of interacting particles is always conserved. Okay, that is, if two particles collide with each other or interact with each other, their total momentum before the interaction will be equal to that after the interaction. Okay, once we have made a statement, this is physics, we will always have to come up with the proof. Let us check the proof. Consider two bodies A and B. Okay, let there be two bodies A and B with initial momenta PA and PB. Okay, the initial momentum be PA and PB respectively. When the two bodies collide or interact, they get apart. Okay, there were two bodies A and B. They interacted with each other and they went apart. Okay, this is A, this is B. Now after the interaction or collision, let the momentum be PA dash and PB dash respectively. By Newton's third law of motion, please recall Newton's third law of motion, equal, there is always an equal and opposite reaction to every reaction. Okay, during the collision, the force of one body is equal to the force on the other body. Okay, force FAB is force exerted by ball A on ball B or particle A on particle B. FBA is force exerted on B by A. Okay, one is pushing in the opposite direction to the other. That is why this negative sign. Okay, so let us check. If delta t be the time for which the interaction or collision takes place, then the impulse, please remember impulse, capital J, okay, force acting for a very small period of time, delta t. Okay, the impulse acting on A is given by force into time. What is it? It is a difference in momentum. Okay, please recall impulse is change in momentum, which is final momentum minus initial momentum. Final momentum is P dash A and initial momentum is PA. Okay, similarly, the impulse acting on particle B is given by PB dash minus PB. Okay, so from equation 1, where we said that F of AB is equal to minus F of BA, I will equate FBA and FBB. What do I get? I get P dash A minus PA is equal to P dash B minus PB. Okay, so if I interchange the position of the expressions, what will I get? PA dash plus PB dash. This is the sum of total momentum after the interaction. It is equal to PA and PB. That is the total initial momentum, which means that the total final momentum is equal to the total initial momentum, which is nothing but the law of conservation of momentum. The momentum before an interaction is equal to the momentum after the interaction. Let us check a few more terminologies now. First of them, what is a resultant force? We have already studied this. Resultant force is that single force which produces the same effect on the body as the net effect of all the forces. Suppose this is one body or particle. There are a couple of forces or maybe 3 forces acting like this. Then what is the resultant? The resultant may be 1 force like this. Okay. So it is producing the net effect of all the individual forces on the body. What is equilibrium? A set of forces are said to be in equilibrium if the resultant is 0. What does that mean? There is a particle like this. There is one force acting in this direction. There is another force acting in this direction. Okay. Opposite forces are acting, which means that the body does not move. Same magnitude forces are acting. This is Fa, this is minus Fa. So the body will stay at rest. Although there are two forces acting, the body will remain at rest because the body is in equilibrium. What is equilibrant? The equilibrant is that force which, when acts together with those forces, keep the body in equilibrium. Say suppose I go back to the same example. I have 3 forces. This is the resultant of the forces. The equilibrant will be opposite to the resultant. This is the resultant. This is the equilibrant. Resultant is sum of the forces acting on the body. Resultant force acting on the body. Equilibrant is opposite of the resultant force. So there is one body. There are 3 forces acting on it. The equilibrant is acting in the opposite direction so that it nullifies the effect of these 3 forces. Thereby, the particle or body shall remain in equilibrium. Okay. What is equilibrium? The particle is said to be in equilibrium if the net external forces acting on the particle is 0. There may be 1, 2, 3, 4, 5 forces, but if the effect of these 5 forces on the particle is 0, then the body or particle is said to be in equilibrium. What is equilibrium under 2 forces? Let there be 2 forces, F1 and F2, acting on a particle or a body. The particle will be in equilibrium mathematically if F1 plus F2 is equal to 0, or if F1 and F2 are 2 forces which are equal in magnitude and acting in opposite direction, or in simple words, F1 is equal to minus of F2. That is, when 2 forces are acting on the same particle, they must be equal and opposite so that the particle shall remain in equilibrium. Okay. Few of the important terminologies that we must have known. Now coming to, in the previous slide, I talked about so many forces, F1, F2, F3, F4, etc., etc. What are the types of forces? Let us have a look. Common forces in mechanics. Please remember, our study is on mechanics. What are the common forces? I can classify it broadly into 2 types. One is contact type forces. The other one is non-contact type forces. What is this contact type forces? Contact type forces are those which require a physical contact to act. Okay. What are the examples? Friction. If there is no interaction between 2 surfaces, there is no friction. It requires a physical contact, as simple as that. Similarly, a spring force, tension on a string. You tie a rope to a stone and try to pull it. There must be contact between the rope and the stone, otherwise there will be no effect. So these are called as contact forces. Then what are non-contact forces? For example, gravitation. Whether I am standing on the earth, in the air, or on an aeroplane somewhere in the sky, gravitation will always try to pull me down. That is the effect of a gravitational force. It is non-contact in nature. Similarly, magnetic field, it will always try to pull a ferromagnetic material. Okay, any magnetic material will be attracted towards a magnet, whether it is in contact or not. Similarly, the electrostatic forces. So these are the classification of common types of forces in mechanics and a few examples. Let us also speak about weight and mass. Generally, when someone asks us what is the weight, we express that in terms of kg. Because we are on earth, okay, our weight and mass are often misunderstood. let us have a closer look at what is weight and what is mass. Weight is the gravitational force exerted by the earth on a body. Okay, there is an object or a body of mass m. The gravitational force is g. So weight is equal to mass into gravity. Weight is mass into gravitational force. Then what is mass? It is the amount of matter contained in a body. The amount of matter contained in a body is called as mass. Mass multiplied by gravitational force is called as weight. Okay? Is that understandable? Weight is mass into gravitational force. M is mass, G is acceleration due to gravity. Please remember, weight, the direction of weight is along the vertical and always towards the center of the earth. The gravitational force is always acting towards the center of the earth. Let us try to differentiate between the two so that it makes things more clear. Mass is the amount of matter contained, whereas weight is the gravitational force acting on a body. Okay? Please remember, mass is always a scalar quantity, whereas weight is a vector quantity. Okay? Mass of a body shall remain the same at all places. What do you understand by all places? Whether it is Earth, whether it is Mars, whether it is Jupiter, whether it is Moon, anywhere you go, the mass remains the same. But what happens to the weight? Weight of a body varies from place to place depending on whatever is the gravitational force on that entity. Okay? What is the unit of mass? Mass is given by kg, whereas weight is kg meter per second square. Okay? So this is the difference between mass and weight. Let us now come to what is spring force. Okay? The force exerted by the deformed spring. See, once you have a spring, you can either compress the spring or stretch or expand the spring. Once you compress or expand the spring, the force exerted by that deformed spring on the object connected to it is called as spring force. See, this is a rigid body. One end of the spring is connected to the rigid body, the other one is connected to an object. Okay? You pull this object, the spring gets expanded. You push this object towards here this way, the spring gets compressed. Okay? The force exerted by that compressed or expanded spring on that object connected to it is called as spring force. It is given by F is equal to minus K into X, where this K is the spring constant. X is the change in length. Okay? X is change in length of the spring. It may be in positive direction or in negative direction depending on whether you are expanding it or you are compressing it. Its direction is along the spring and away from the object. Okay? So this is basically spring force. Let us now speak about tension. Okay? Tension on a string. Please observe here, there is a huge rock or stone placed on a floor. This person has tied a rope or a wire or a string and is trying to pull this stone. Okay? This is the scenario. The force exerted by a string or a thread or a rope on the object to which it is attached. So whatever is the force exerted by this rope on this object, that is called as tension. Okay? It is given by the equation T is equal to M into G, where M is the load placed in weight hanger, okay, or it is the weight of this object, and G is the acceleration due to gravity. Okay? So we have studied about the spring force and the tension on a string. Now let us come to some very important concept which is called as normal reaction. Let us first try to understand the word normal. Normal simply means a perpendicular to a given line. A perpendicular to a given line, which means that it is at 90 degree. Okay. Let us get some context into it. The component of contact force normal to the surface in contact is called as normal reaction. There is a surface. This is the surface. This is the object that we are talking about. What is the normal? The normal is that force. The normal is that force which is acting perpendicular to the surface. Why is there a force acting? Because by the self weight of the object, which is W is equal to mg, a force is already acting towards the center of the earth, downwards. Okay. If the body is at rest on a horizontal surface, the magnitude of the normal force is equal to the weight of the body. Okay. So what is the magnitude of this normal force? This N is equal to mg. Okay. When is N equal to magnitude of the force? If the body is at rest on a horizontal surface. When the body is on a horizontal surface and at rest, the normal force is equal to m into g. What will happen if there is an inclined surface? Suppose the inclination is theta. What will happen to that normal force? On an inclined surface, n is equal to mg cos theta. On a flat surface, it was n is equal to mg. On an inclined surface, it is n is equal to mg cos theta. Please remember, normal is a line perpendicular to the surface on which the body is resting. Okay. We will use this concept of normal reaction for further equations. Okay. Now let us come to friction. What do we understand by friction? What are the types of friction? So on. It is the property by virtue of which the force opposes the relative motion between two surfaces of bodies in contact. Please imagine a desk or a chair at your home. Okay. It remains as it is until you try to lift it or you try to push it. If you try to lift it, the weight of the chair will try to pull it down. If you try to push it, friction will offer some resistance to you. Unless you apply a force to push it or pull it, the friction will not act. It will come into existence only when you try to change its position. Okay. Property by virtue of which the force opposes relative motion between two surfaces of bodies in contact. Okay. Frictional forces are due to the roughness of the surfaces and molecular force of attraction at the points of those actual points. Here, the kid is trying to push this box. Okay. And he wants the box to move in this direction. In which direction will the friction force act? Obviously in the opposite direction. Please remember, if the boy was pushing the box in this direction, the box would try to move in this direction. Friction here would have acted in the opposite direction. Friction always acts in the direction opposite to that of the relative motion. Okay. It also depends on the nature of the surface. If the surface is finely polished, the amount of friction will be less. If the surface is rough, the friction will be more. It is the force which opposes the motion of one body over the other in contact with it. Okay. When two bodies are in contact with each other, and if it tries to slide one above the other or move with respect to each other, relative motion is there. Then it tries to oppose that. That is frictional force. Direction of frictional force is tangential to the two surfaces. It is tangential. Suppose you have a surface like this and then there is a body. Friction only acts at this point. It is tangential. It is acting at only one point. Okay. It is tangential to the two surfaces in contact and opposite to the relative motion. This is what I have been explaining throughout this slide. So whatever is the direction of motion that you want to push the body, the friction will be always acting in the opposite direction. Let us now try to have a look at the types of friction. First one of it is static friction. It is a frictional force which balances the applied force when a body is in the state of rest. Static friction is applicable when a body is at rest. Okay. Consider a body on the floor. When the body is pushed with a small force, it does not move. Okay. There's a huge boss. This person is trying to move it with a small force. It's just trying to push it. Okay. With a easy go mind. The body does not move because the floor exerts a frictional force on the body which balances the applied force until the force with which you push it is greater than the weight of the body. Only then it will move, otherwise it will not move. Static friction is equal and opposite to the applied force. Okay, so that was about a static friction which acts when a body is at rest. Let us check what is limiting friction. It is the maximum static friction. So it is the friction which is maximum when a body is at rest, that a body can exert on the other body in contact with it. Floor applies a certain amount of friction on the body which is resting on the floor. It is also called as a self-adjusting force. Please remember, this might be a question in your competitive examinations. Limiting friction is also called as a self-adjusting friction. Okay. Moving on, the force of limiting friction is directly proportional to the normal reaction. Okay, Fs is directly proportional to the normal reaction between two surfaces. So Fs is proportional to N. So what do? I use something called as the frictional coefficient as the proportionality constant. Mu s, we call it as mu. Mu s is equal to Fs by N, where mu s is the coefficient of static friction and N is equal to mg or the normal reaction. What is this coefficient of static friction? It is the ratio of force of limiting friction to the normal reaction between two surfaces. Mu s is equal to Fs by N. Coefficient of static friction does not have any unit. Okay, it does not have any unit. Let us check. We have studied about friction on a body at rest. Now is the time to study about friction on a moving body. Let us see what is kinetic friction. It is the frictional force acting between two surfaces when one surface moves over the other. When two bodies are in relative motion with each other, then kinetic friction comes into picture. When the body was at rest, static friction was there. Consider a body moving on the surface of another body. Okay, there is one box which is sliding over a surface or which is being moved over a surface. The kinetic friction acting on the body due to the surface of another body will be opposite to the direction of motion. If the body is moving in this direction, kinetic friction will be acting in the opposite direction. Okay. Coefficient of kinetic friction is given by mu k. It is the ratio of kinetic friction to the normal reaction. Mu k is equal to Fk by N. Okay. Let us try to discuss further about kinetic friction in terms of angle of friction and angle of repose. What is angle of friction? It is the angle made by the resultant of the limiting frictional force to the normal reaction. Okay. Now, I have an inclined surface and the body is on the inclined surface. How was the normal? The normal to a flat surface was like this. How will be the normal? The normal will be like this because it has to be perpendicular to the surface. Okay. So, angle of friction is the angle made by the resultant of the limiting frictional force and the normal reaction. So, how will the frictional force be acting? Okay. The frictional force may be acting in this direction. Okay. Or it may be acting in this direction. So, whatever is the angle made by the frictional force with the reaction, that is called as angle of friction. Okay. What is angle of repose or angle of sliding? It is the minimum angle of the inclined plane for which a body lying on it just begins to move. So suppose this is the horizontal, okay. Whatever is the minimum angle at which any body which is on this inclined plane starts to move, that is called as angle of repose or angle of sliding. Without any external force, based on the inclination, the body automatically starts to move. That is called as angle of sliding. Now coming to another interesting concept called as rolling friction. What are the two types of frictions that we checked? We checked about static and kinetic friction, where a box was being moved. Now let us think about a rolling motion, okay, to make things interesting. The force which opposes the rolling motion of a body is called as rolling friction. Suppose a ball is being rolled on a floor. I have taken the example of a wheel here. Okay, a wheel is being rolled. The friction will be in the opposite direction to that of the rolling of the wheel or the ball. In principle, a body like a ring rolling without slipping over a horizontal plane will suffer no friction. Ideally, it should not suffer any friction because it is being rolled over. But practically, that does not happen. In practice, there is some resistance to motion. Okay, rolling friction has a complex origin. It is slightly complex, okay, and somewhat different from that of static and kinetic friction. Okay, so our study regarding rolling friction in detail will be at a very later stage. For the time being, let us understand that rolling friction is much smaller than kinetic and static friction. Because a ball or a ring is being rolled, the contact area is very, very small. Hence, the friction will also be smaller. Okay. Now, there are certain laws which govern friction. We cannot study them in detail, but we can definitely have a look at the statement of these laws. There are 5 laws which govern friction. Let us check them one by one. The direction of static friction is opposite to the impending motion. So, if a body is moving in this direction, friction will be in this direction. And the magnitude is given by Fs is always less than or equal to mu s into n. Static friction will be less than the product of mu s and n. Equal to is the highest one. Okay. Second, the direction of kinetic friction is opposite to the relative motion. There also, if a body is moving in this direction, the kinetic friction will act in this direction. The magnitude is once again given by Fk is less than or equal to mu k into n. The values of mu s and mu k depends on the nature of the surface, whether the surface is rough, smooth, polished, so on and so forth. And mu k is generally less than mu s. Coefficient of kinetic friction is generally less than coefficient of static friction. It is always difficult to move a body from rest than to move a body which is already in motion. Please remember this. It is always difficult to move a body from rest than to move a body which is already in motion. The coefficients of friction are independent of area of contact. Okay, so the area of contact does not play a role in the value of the coefficient of friction, provided the normal force is constant. But there is an exception to the rule. If the material is sticky in nature, if it is like rubber or soft plastic, then the area of contact will definitely have a bearing on the coefficient of friction. Kinetic friction is nearly independent of velocity. Okay, so velocity does not play a role with the kinetic friction. These are the 5 laws which govern friction. Let us check what are the advantages of friction. We have talked in detail about what is friction, what are the types of friction, what are the laws that govern friction. Let us check what are its advantages. Will I be able to walk without friction? No, sir, I will slip off. So I need friction to walk. Will I be able to write with a pen on a paper? No, I require friction. Will I be able to write on a board? No, I require friction. Will I be able to count notes? No, I require friction. Will the brakes on an automobile work without friction? No, if there is no friction between the tire and the road, brake will not work. Okay, it will just slide on the road. Will I be able to light a matchstick if I don't have friction? I require friction, otherwise the stick will slide on the matchbox. Okay, to hold a glass, to walk, for an automobile to stop, to write on the board, to fix a nail on the wall. Okay, for walking, for playing, to climb a tree, etc., etc. Most of the cognitive work that I do, I will require friction. Most of the cognitive work that I do, I'll require friction. Okay, these were the advantages. Obviously, we have to check the disadvantages. Science will have both advantages as well as disadvantages. What are the disadvantages of friction? It reduces the efficiency of the machine. Why is the efficiency reduced? It produces huge amount of heat which is harmful to the machine. What do we generally do in cold conditions? We rub our hand. Because of friction, some amount of heat is generated. So this generated heat will be of much higher magnitude in terms of machines where there will be relative motion. This heat will reduce the efficiency. Because of higher temperature, the parts will wear off or it will get completely broken off, wear and tear of machine parts. Speed of the automobile cannot be increased beyond a certain limit. Why? Because there has to be friction between the tire and the road. Okay, so these are few of the disadvantages of friction. Now, once I say that there is some disadvantage, how to reduce it? Okay, that is quite important. How do I reduce the friction? Methods of reducing friction. What do I do? Friction can be reduced by polishing. I can polish the surface like a mirror finished one. Okay, I can lubricate. I can make use of a lubricant so that the part slides over the other smoothly. Okay, selection of an anti-friction metal. The metal can be such that the friction is very, very minimal in nature. Using ball bearings. Most of the bearings are employed so that friction can be reduced to a minimal level. Streamlining of motion. So, once there is a motion between two parts like the shaft and the cylinder, so you can check how streamlined it is so that friction can be reduced. Are we only discussing about reducing the friction? No. There could also be a certain case where I need to increase the friction. How do I increase the friction? I can increase the friction by sprinkling some sand on a slippery road. Okay, if you feel that the wheels will slide off, if there is a snowfall, the wheel may tend to slide off. Okay, if you are on a cliffy road like in the Himalayan mountains in India, you may just slide off the road and fall down. Okay, so what do? You can sprinkle sand on a slippery ground, or you can use the synthetic tires which provides better friction. Okay, so we have discussed in depth about friction today. Have a wonderful learning experience. Thank you.